Hello, everyone. Welcome back for another math lesson with Mr. Hopkins. Today we're going to continue factoring and finding the zeros of an equation, also known as the roots, and where they cross the x-axis. So the first couple, little bell ringer that I have to start the class, should be a warm-up after the first two lessons, and since it's from a previous lesson. So here we go. It says, find the roots. So let's factor it. Always look for a GCF first, but in this case, there is no GCF. Factors of x squared, x times x, and factors of 20 that add to get negative 12. In this case, we have negative 10 and negative 2. They add to get negative 12. They multiply negative times a negative, positive 20. So what we do to find the roots, we set each piece equal to 0. X minus 10 equals 0, and x minus 2 equals 0. On the left, to get x by itself, we add 10 to both sides. So basically, I want to get rid of the negative 10. Whenever I cross an equal sign, its sign changes. So if I take negative 10 over there, x equals positive 10. You can think of it that way. It's a little easier. When I take negative 2 to the other side of the equal sign, it becomes positive 2. So my two roots are 2 and 10. All right, next one, number 2. In this case, there is a GCF. They both have a 2 in common, and between x squared and x, they both have an x. So if I take that out, I'm left with x plus 9. Again, t-bar it. Set each piece equal to 0 and solve. So if I divide both sides by 2, x equals 0 and x equals negative 9. Okay, from a graph, remember the zeros? They're right here, 1, 2. So x equals negative 2 and x equals positive 3. So that one was easy. And if you're ever stuck, plug those equations into y equals, then go to your graph. You'll see where they cross. When they're fractions, though, that's when it gets a little tricky. Okay, number 1. If the zeros of the quadratic are negative 2 and 4, write the quadratic equation in standard form. Well, if I needed to work backwards, if these are the zeros up here, so x equals 10, I know its factor is x minus 10. X equals 2, its factor is x minus 2. So what I do is I switch the sign. I negate the sign, and then I set it equal to 0, or most equations equal y. So if I do y equals, instead of, if my 0 is negative 2, then its factor is x plus 2. If my 0 is 4, then its factor is x minus 4. So I kind of negated that. So now I have a binomial times a binomial. We can use the box method to multiply that. We've seen this before, but I'm going to refresh your memory. X plus 2, x minus 4. So let's multiply x times x, x times 2, negative 4 times x, and negative 4 times 2. Like terms are always diagonally for the most part. I start with top left, we have x squared. Negative 4x plus 2x is negative 2x. And I end with negative 8. There's my quadratic equation whose roots are negative 2 and 4. Okay, so we just have 4 quick questions on factoring and finding the roots. Always look for a GCF first. In A, they all have a 3 in common. So I'm dividing that out. And now I can factor what's remaining. Factors of 12 that add to get negative 6. I'm sorry, factors of negative 12 that add to get negative 4 are negative 6 and positive 2. And then I set each piece equal to 0. So on the left, 3 equals 0. That doesn't even make sense. And because we know that's not true, we reject it. Over here, x minus 6 equals 0 and x plus 2. So we've got x equals 6 and x equals negative 2. Good. B is tricky when we factor. It's not difficult, but we tend to make a mistake. We both know they both have an x, so let's factor out the x, and what's left is not just x. A lot of us only want to write the x, but remember, we have to distribute this and get our answer back. So x times x is x squared. Well, how do I get that x back? I have to show a 1 in there. So if I divide the whole thing, anything divided by itself is 1. So x times x is x squared. X times 1 is x. It's fully factored now, so let's go ahead and set each piece equal to 0. There's 1. So x equals negative 1. All right. C. They're all even, so I know they're divisible by 2. And then I'm going to set it equal to 0. So I did 2 steps there in one. Factor. Factors of 24 that add to get negative 5. Negative 8. Positive 3. Multiply to get negative 24. They add to get negative 5. Once again, we know 2 does not equal 0, so reject that. So 8 and negative 3. And the last one. Again, look for a GCF. 10 goes into both of those numbers, and they both have an x. So again, when I take the whole thing out, 10x divided by 10x, I have a 1 in there. Divide both sides by 10. X equals 0. And again, divide by 2. So 0 and 1/2. Okay, so this was our third day on that. Just factoring, solving for the roots. If you have any questions, please reach out.